A mushroom was taught to crawl after being hooked up to a robot body. I love how ridiculous this statement is. It's so ridiculous to me, this statement. Oh my god, dude. Controlled by a mushroom. The kind of mushroom used to power the creation of a king was a king trumpet, which controls the movement of the two biohybrid robots instead of the typical power sources, such as mains, electricity, or battery. Oh my god. They sent signals to allow the fungi to sense and respond to the environment. I'm so glad that we're teaching mushrooms to walk, dude. That's the best. Harnessing the mushroom's ability to sense chemical and biological signals may be beneficial in the future, particularly since mushrooms can survive in challenging conditions. You know, I'm going to be honest with you. I can't wait until we train fungus to run robots. That's going to be the best. You say nope, I don't give a shit. Do you want to know why? Because the mycelium is what they're talking about. They're not thinking about a mushroom. So if you don't realize this, the mushroom is actually the fruiting body of a fungus. The fruiting body is like an apple. So when you see a mushroom, the mushroom itself is actually like the apple, and the mycelium is everything down here. It's like roots, and then you eat the thing that pops out of the top of this. So what they're talking about is they're talking about probably an agar plate. It's got agar in it, and it's filled with mycelium. There's no mushroom in there. It's just a fungus. It's just the mycelium. And this will react and send signals. They've even had electrical signals in these before. It's, pretty normal thing. It's actually kind of cool. The interesting part is, what does it do? Is it just sending random signals and they're interpreting those random signals, or is it sending signals in a deterministic fashion? So I want to read the research paper about this to understand more, because we've done very interesting things with certain animals before to learn. I'll give you an example. If we look at slime mold, train station, train map, there we go. So something that they used is a slime mold specifically for the Tokyo rail system to try and see if they can improve the Tokyo rail system. And this is the Tokyo rail system and all the locations for it, and they put a little piece of oat on each one of those, and then they unleash a slime mold. The slime mold finds all the oats, and then it tries to optimize its strategy by doing the closest locations between each one to transfer nutrients between them. And they can redesign train networks using a slime mold this way, which is really cool, actually. So there's a lot that we can learn from this, a lot that we can learn from that, and then be like, wow, we can actually make our systems more efficient by doing this. Yeah, we've done it with ants as well. It's very cool. It needs topology. It would. Yeah, it would need topology. I mean, in this case, it would be underground, so not really. You just build tunnels, so it's not really that big of a deal. But I do think it's quite cool, legitimately, to see us using biohybrid to produce really interesting results. And it's funny because a lot of people be like, oh no, you can't take that data because it's not clean enough or whatever like that. We have to use only machine. But it's no, there are things that get solved faster using biological things, like a slime mold, faster than our current algorithms. And we learn to write better algorithms by investigating and watching the natural world, which is quite cool. Yeah, nature knows things before we do. Bingo. So an entomologist buddy of mine was talking to me last night, and we were talking about a research paper specifically for ants. So they've been doing 3D printed oak galls, which is like a big knot of wood. And they're trying to use them as artificial nests for arboreal ants. And the reason that they're doing this is, we go and look at this. You can see this is an oak gall, and this is a 3D printed fake one. And what they're doing is they're putting these in trees so that the ants move into them, so the ants can be a natural pesticide. So all they do is they put these up there so there's a habitat for the ants, and the ants actually go and reduce the amount of tree-damaging pests because they're protecting the tree, because the tree's their home and they go for it, and then that's what they do. So you can actually reduce the amount of pesticides used, chemical pesticides, by introducing ant habitats into the environment, which is just a really cool research paper. It's actually a really neat one. And I think this is the kind of stuff that I'm very interested in. And you can see leaves being damaged, the amount of leaves being damaged is without ants, the amount of leaves damaged is quite high. With ants, it's dramatically reduced. So they've got all the research paper information here, and I just think it's cool. I think it's really good shit. So I love this stuff. I love this kind of research, and I think it's neat. I think the idea of researching this for specifically mycelium and chemical markers out of that is also kind of cool, because you create weird wetware with that. Yeah, it's like hiring ants as bodyguards. That's exactly what it is. And I love these types of research papers. So it's very neat.